So the last thing that that they have you do with this form is the beginning of some basic factoring. This is a part. So we're going to be using the distributive property in reverse. I think we've done this before, okay? But for instance, right, if we were presented with 3x times x minus 4 plus 5 times x minus 4 equals 0. How is this similar or different to something in this form?
Because it has plus 5 in the center and equals 0 on the outside and 3x on the left side.
Okay. So does that make it similar or different to the thing above it?
Well, technically, it's pretty similar. I mean, you know.
What's similar? What's different?
Well, what's similar?
Go ahead, Annie.
Yeah, go ahead, Annie.
Another thing that's different is that it's not minus a and minus b, because a and b are actually the same in the bottom one.
Okay. And notice it's not exactly the same because here everything is being multiplied, right?
Mm-hmm.
Here there are some terms being added or subtracted. Okay? So we want to get this into this form. Okay? Now, remember, okay? If I'm going to multiply two binomials, right? I do it like this. I can do it like this. Where I have x and minus a and x and minus b, right? And this would be x squared negative ax negative bx, and this is ab.
Mm-hmm.
Another way to look at this is, watch, it's x times x minus b plus negative a times x minus b, right? So look at that form. X times x minus b minus a times x minus b. Okay? Does this look like something anywhere else on the board? Does this look at all like this?
Yeah.
Right? So notice, I went x minus a times x minus b. That got me to here, which got me to here, right?
Mm-hmm.
So I can go the other direction. So I can take something that's in this form and write it like this. So this can be rewritten as 3x plus 5 as a binomial times x minus 4.
That's getting confusing now.
Why?
Like, why would you add 3x to plus 5? Because it's on the outside?
So what we're doing is we're saying...
Wouldn't you have to square it, too?
When
you have to square x minus 4 since there's two of them?
So it's sort of like... So... It's sort of like... Let me think. If I have 7 times 2 plus 3 times 2, okay?
Mm-hmm.
7 times 2 plus 3 times 2. This is 14 plus 6 equals 20, right?
Yeah.
Or we could say it is 7 plus 3 times 2, the distributive property. I did the distributive property backwards because if I had it this way, right, and I could get to here by going 2 times 7 plus 2 times 3. That's the distributive property. Distribute the 2, right? And look, sure enough, 7 plus 3 is 10, times 2 is 20. I get the same result regardless of how it's written. So over here, instead of 2, I have x minus 4. So my value that's being multiplied by both things is x minus 4. So it's as if I were to take this and distribute x minus 4 to the 3x and distribute x minus 4 to the 5.
Yeah, same answer.
Okay? But what the benefit here is, I now have this in a factored form where everything's being multiplied, so I can solve the equation easier because a value of x that I put in here that makes this 0 is a solution, and a value of x that I put in here that makes this 0 is a solution. Okay? So which one of those is easy to do? If I'm looking at those two binomials, which one is very easy to see a value of x that makes it 0?
X minus 4.
X minus 4, because for that one, x equals what makes it 0?
4.
When x equals 4. So I go like this. I go, okay, so if x minus 4 equals 0, then x equals 4. Or, I can also say, what happens when 3x plus 5 equals 0? How do I solve for x here?
The x should have to be like a negative or something.
Go ahead.
No, never mind.
What were you going to say?
I forgot what I was going to say, so I said never mind.
Okay,
The x would have to be a negative 8.
walk me through the steps. What's my first step to solve this equation?
It's finding out what the x is. Because
That's my ultimate goal. In order to find out what the x is, what do I do first?
You add 5 and 3.
Nope. I cannot combine these two terms because they are not like. Right? This has an x on it, this doesn't. So I'm going to isolate the variable by subtracting 5 from both sides. I'm left with 3x equals negative 5. Now I'm going to isolate the variable by dividing both sides by 3. X equals negative 5 thirds. Okay? So the solution to this original equation is x equals 4 and x equals negative 5 thirds. And or.
You put the 4 before the negative 5 thirds because it's a greater number, right?
No, just because, for no reason at all.
Oh, okay. So it doesn't matter?
Doesn't matter. Shall I do another one of these?
Mm-hmm.
Also notice that this solution is, so when I have something like this, I just take the opposite sign of this constant number. So whereas this is negative 4, the solution is 4. Here, I went opposite sign of this, divided by that coefficient. Negative 5 divided by 3. Okay? Because this is the work that gets me there. Okay? The other example is negative 9 times x plus 2. Plus 3x times x plus 2 equals 0. So how am I going to get that into a factored form?
Negative 2 is x.
Well, that's one of them. But remember, the first thing I want to do is get into a form where I have an x minus a and an x minus b, like a.
You just
3x minus 9 in parentheses times in parentheses x plus 2.
wait. Can you do it oppositely, like 9 minus 3x?
Well, it would be negative 9 plus 3x.
Yeah.
Okay.
if you do
Which,
it.
and the reason you're saying is because it's written this way. Annie, why did you put the x first?
Because now it's a habit to descending powers of the variable.
Yes, that's a good habit to have. Always write things in descending powers of the variable.
So,
So-
you can choose them?
Say it again.
You can choose them?
Choose what?
These.
Well, notice this is still a positive 3x. This is still a negative 9. So they are the same numbers that are here, but since we're adding them right here, addition is commutative. You can change order without changing the value. So I can change their order however I want. We always prefer to put it in descending powers of the variable. Okay? So now AJ had called out one of my values of x, right? So if x plus 2 were to equal 0, that would mean x is negative 2. And then I have if 3x minus 9 equals 0, I would add 9 to both sides. I'd have 3x equals 9. Divide both sides by 3, x equals 3. Okay. So my solutions are x equals -2 or x equals 3. Or and. It's both. Both are solutions. Okay? And then there's one more type. One more type that you might see. Take a look at, we're going to do together number 9 on page 963. So is not yet, is under your turn, so you can write in what I'm going to do. Okay? So it goes, anyway, read it out to me.
-8x, open parentheses, x plus 6, close parentheses, plus 3x, plus 18 equals 0.
Okay. So how is this one different from the ones we've just done?
There's only one thing in parentheses and everything else is being added.
Yes. So the first thing we want to do is find another one of these guys. Right? Why do I want to find another one of these guys, Christian? Or what is this guy I'm referring to?
The x plus 6.
The x plus 6. Okay? I want to find another x plus 6. Does anybody see where I might find another x plus 6?
3x plus 18.
Yeah, what about it?
3 has x and 18 is divisible by 6.
Yes. When I divide 18 by 6, what do I get?
3.
3, conveniently, right? So this, if I take so I have -8x times x plus 6. Now, I can factor this using the distributive property to be plus 3 times x plus 6. Okay? Notice, I could have figured that out. I could have figured that out just by looking at it, but I had a clue. I had a clue because there was already an x plus 6 here. So I was looking to get another x plus 6 in this expression right here. I wanted to find another x plus 6 because it'll make it easier to get it into factored form. Okay? Now this looks just like the last two that we did. So now I take these two pieces and make a binomial out of them. -8x plus 3 times x plus 6 equals 0. So now I solve x plus 6 equals 0, means x equals -6. -8x plus 3 equals 0. Subtract 3 from both sides. -8x equals -3. Divide both sides by -8. X equals 3/8. So, solutions are x equals -6 and x equals 3/8. Cool?
Bless you.
Cool. Awesome. And there are some word problems. So if you're doing a word problem, you're just looking for where in the situation they're describing is the stuff we've just done. That's what you're trying to do on a word problem. Okay? Find numbers in the story they're telling in the word problem that fit the work we've just done. Okay? So there's one or two of those on each assignment.